Good morning, everybody. Today is our first day of fluids class. The number of this class is ES 2330, and the title of the class is Fluid Dynamics Mechanics. What you see on your screen right now is the computer screen for our Moodle page. The way that you access our Moodle page is through the NWC portal. So you'll type in my.nwc.edu. Yours will look a little different than mine because you are a student, but basically you'll have this Moodle block, and you'll click here on Fluid Dynamics Mechanics, and then you will see this page. So our Moodle page will contain everything that you need to do in order to complete the class, and today we're going to go through all of the elements of the class and how that we're going to work. So the first thing that we're going to access is the syllabus. It says it was revised, but it was I need to change the revision date because I just changed this morning so that we have all of the accurate data on here. This also has a very detailed schedule for the class so that you'll know what is due and when everything is due. So to go through this, like we said, ES 2330, Fluid Dynamics, Spring 2018. It's a 3-credit class. We meet once a week at your discretion, Wednesday at noon. So you're not required to be here for the Wednesday at noon meeting. You're required to do all of the elements on the Moodle page, but this is a time when you can ask questions and make sure that you're up to speed, that you don't have any misconceptions, that you haven't missed anything, and so forth. You're also always welcome to come by my office as usual. The office hours that I have this semester are Tuesdays from 1 to 2, Wednesdays from 1 to 4, and Thursdays from 1 to 2. But the best way to get a hold of me and to have time with me uninterrupted is to send me an email and set up an appointment, because that way I'll put you on my calendar and it is official and nobody else can interrupt us. So this class is a requirement for most fields of engineering. A lot of people take this course. It's a prerequisite if you are in mechanical engineering or in water resources engineering, or if you're in petroleum or chemical engineering. So if you're in any of those fields, this course is very important. Also, if you're a mechanical engineering student who plans to transfer to the University of Wyoming, this course is one of the 10 courses in the Success curriculum that is required for you to complete before you can take any mechanical engineering courses at UW. Now I'm saying that's very specific to University of Wyoming, and it's very specific to mechanical engineering at University of Wyoming. If you're going elsewhere, this is not a problem. But the deal at UW is that in those 10 courses, which are the 3 calculus courses plus 7 engineering science courses, you have to have them completed with an average of a 3.0 or a B in order to progress. And it's nobody really asked me. It's not my business, but I don't necessarily agree with that. But there it is. So, so a lot of people like to take this course in advance of going to UW, so that when they go there, they can hit the ground running. So you really want to get a B. That's the goal. If you get a C, you have to get an A in something else to balance it out. So what are we doing in this course? We are going to study incompressible flow of ideal and real fluids at rest and in motion. Fluids are defined as being either liquids, vapors, gases, or a combination of these. The effects of static forces and compressibility are given special attention. We talk about kinematics, dynamics, flow resistance, and the physical effect of flow. And we also talk about potential and stream functions, similitude, and dimensional analysis. And if you don't know what all those things are, that's okay, because that's what we're doing here. So we're going to learn all of that stuff. The big deal is you really need to have Calc 3 successfully completed before you take this course, because the math level requires that. Not right out of the chute. The first couple of chapters are kind of more geometry and maybe a little bit of Calculus 1 and definitely algebra. However, you'll notice when we start getting into especially finite control volume analysis and the Navier-Stokes equation, you are definitely going to be wanting to refresh yourself on your calculus 1, 2, and 3. So if you don't have Calc 3 under your belt, please let me know, and we'll discuss what that means for you. You can also get in here, you can have either Dynamics or Physics 1, but there's an alternative prerequisite if you've completed Statics and are currently in Thermo. That will work as well. That's also assuming, of course, that you have the math level that's required for this course.
So you need Dynamics to be in here?
Or Physics 1. Or Statics and Thermo. So there's a couple different ways you can do it. So, yeah. As long, the real big deal, though, to tell you the truth, Jacques, is the math. You know, I mean, if you're in Calculus 3 and you're solid with your background, you're going to be fine. So, but that would kind of get you, there's just sort of some alternative credentialing so that we can let more people in who are appropriately, who are at the right level. So any of those will work. So anyway, continuing then, the course outline, you'll see we have chapters 1, 2, 3, 4 in their entirety. Then we get into chapter 5 and 6, where we do parts of those chapters, parts of 7, 8, and 9. And then chapter 12, which is not in the physical hard copy book, but is only on the ebook, which is on the website. I'm going to have you write a paper from that. Not do any problems about turbo machinery, but I like to see you read that chapter and write a 2-page paper about a particular turbo machine. So the textbook, as we have discussed, you do not need to purchase this textbook, but the text we're using is the 4th edition of the Fundamentals of Fluid Mechanics by Munson, Young, and Okishi. And the reason that you don't have to buy this is I have all of the chapters and all of the tables and appendices in PDF format on our Moodle page. So you can use them directly from there. If you like a hard copy of the book, in order to stay within copyright laws, the reason that I can do this is I have purchased 20 copies of this textbook. So I have 20 copies of the textbook in my office. So I can't offer this class to anybody. I can't offer this class to more people than I have copies of the textbook for. So if you wish to have a copy of the textbook, I'm happy to loan it to you for the duration of this class. And if not, you can use what's on your Moodle page. All right. So going back over here to the Podium PC. Oh, and the other thing, it was really interesting, or to me it was interesting, when I was, what I do is every now and then when I'm just sort of have a few minutes, I go shopping for Fundamentals of Fluid Dynamics textbooks, and I probably have enough now, I won't do this anymore, but I bought a lot of them from Amazon and from Half and from eBay, and I also bought a couple from Barnes & Noble. So when I was doing that, I was looking for cheap textbooks, and sometimes I would get them for $4 or $7, and sort of my upper limit of how much I would pay for it would be $10. Now, the current edition of this Munson text is, I'm sure you can imagine, well over $200. It's a $279 textbook. But the new edition has not changed significantly from the old edition in any profound way. So that's why we teach from the 4th, because A, it's cheap, and B, it's static. Once I did the lectures, I didn't want to change an edition of the textbook and have to change up my lectures very much. So when I was buying the textbook, I had heard before that Amazon had an algorithm that will raise the price of textbooks, or of anything, if it becomes a trending item. So I had bought several copies of the Fluid Dynamics text, and apparently it became a trending item, so the price went from $7 to $200, and I didn't buy any for a while, because I think I was the only person actually buying them. So after the price dropped down below $10, which took a couple weeks, I bought some more textbooks. But so it's true. So if you start buying stuff, the price goes up. I can verify that. Isn't that weird?
Yeah, it makes me mad.
It does make you mad, because it's like, yes. Capitalists, I'll tell you what. So that's it. And you know, speaking of capitalism, textbook textbooks are kind of a tough thing because it's a weirdly regulated industry. I mean, it's not regulated, but it's a weirdly it's a monopoly. And they market the textbooks to college professors, and then you guys have to buy the textbooks. So when I look at a textbook and I'm choosing a textbook, I don't normally look at the same things a student would look at, and they don't ever really tell me how much it costs. So they're like, oh, we'll give you all these, we'll give you great PowerPoints, and we'll give you test banks, and we'll give you online resources. And so then I think, wow, this is a great textbook, and then I sell it, I make you guys buy it, and it turns out it's $300, and maybe it's good and maybe it's bad. So it's taken me a while to recognize this as being a racket, but it is, and so I try to avoid that as much as I can. But the textbook companies will also buy up old editions of the textbook so that after a while you can't get them unless they're really old like this one. Well, I mean, in the scheme of things, the year 2000, so 17 years old. But it's very difficult to get like the 5th and 6th and 7th edition of Munson. So they're still expensive, and like I said, the textbook company buys them up so that then you can't. And anyway, so it's kind of a tough deal. So we'll try to avoid it in this class. The other thing that's really strange is, and you may have noticed this, but as engineering students, there are very few textbooks. I mean, like if you look at the whole collection of textbooks about the fundamentals of fluid dynamics, there's probably only 6 or 7 valid textbooks in the entire world. Whereas if you take public speaking, there's like 2,000 books that you could use. So, and they cost $11. So, so it's a way different market. Anyway, continuing on with the schedule, and once again, this is on your Moodle page. I've given everybody here today a hard copy, but if you need more, you can just print them up. We have a class period. Now, these are not like Wednesday, right? This is like, otherwise it would take us like 3 years to get through this class. This is like what you should do today, Wednesday, Friday, Monday, Wednesday, Friday, and so forth. Now, your math review, which I'll go over with you in just a moment, is going to be due next Wednesday. And I would greatly prefer that you submit it through Moodle. If you're not able to, I'll accept it hard copy, but I will set up Moodle so that you can give that to me on Wednesday by midnight or something like that. Then your Chapter 1 homework will be due.
You said you prefer that hard copy?
I prefer Moodle.
Moodle?
Yeah, no. The reason is because it stays really organized for me, and I can just grade it like everybody's together, and I don't have to worry about papers on my desk and so forth. But I recognize that as a personal problem, so I'm not going to make you do it that way. But it's better. So many times there's a vodcast that you'll watch. I have all of these vodcasts posted up on YouTube as well, on my YouTube channel with all the other stuff. So you don't ever have to do a vodcast if you don't want to. You can always watch them on oh, I'm so sorry. You can always watch them on YouTube. And I did that because sometimes our system is just really slow and the vodcasts are really clunky. The format is just really clunky. So everything that we've done is already, all of the lectures are loaded. The one that we're doing today, of course, is not. So I have to, because of the equipment in this room, I have to write it as a vodcast first, and then they have to give me a file that I can rewrite as an MP4, and then I can pull it up. So sometimes it takes a little while because there's like 4 people involved, which is ridiculous, but there it is, just the same. Anyway, so I will get those posted as soon as possible. But your math review will be due on the 17th, which is 1 week from today. And then your Chapter 1 homework will be due on the 24th, which is 2 weeks from today, and so forth. We are only going to have 2 exams in this class. We have between 8 and 10 homework assignments, and well, actually between 9 and 11 homework assignments, and then we have 2 exams, just a midterm and a final. Okay. Now, I have some material on here. For example, you see it says we have a conference, either phone or face-to-face, but what we're doing in this class counts as that conference. So in other words, if you are not able to see me in between tests or in between homework assignments, you have to make a point of coming to see me or talking to me over the phone. But if you just come to class all of the time or most of the time, that's not a consideration. more for the students out in the ether than you guys. Okay, so after we do chapter 4, we'll have a proctored midterm exam. It takes about 2 hours, and you can make an appointment, or we can just do it in here. You know, you can start here if you can stay from noon till 2. I don't know if you guys have 1 o'clock classes. Yeah, how about 11 o'clock classes? 11s? Okay, so we could start at 11 on Wednesday and go till 1 on Wednesday. And if that doesn't work for you, we just set a time. But that's just a convenient way to bring us together, if that's what works. So we're going to have that proctored midterm right before spring break, which is pretty early this year, the 5th of March. Then we'll do chapter 5, chapter 6. We have the spring holiday, or what I like to call the holiday formerly known as Easter. So, yeah, I like Easter, but there you go. So we do chapter 6, then chapter 7, and chapter 8. Chapter 9 is, I have 2 different approaches to chapter 9. I've recorded 2 sets of vodcasts and done 2 different homework assignments. I'm really not sure which one I like best, but you don't have to do all of it. You have to do just one or the other, and I will make that determination prior to getting there. Then the last thing that we do is you read chapter 12 and tell me what kind of a turbo machine you like, that you'd like to write a paper on. It can be an impeller, it can be a pump, it can be an airplane engine, it can be a wind turbine, just something that's of interest to you, something that spins and either makes electricity or uses electricity, really is kind of what I'm after. And then you write the paper, you get a grade for that. It's a homework grade. Then on April 30th, we will review for the final, and then we'll have a proctor final. So your grade is comprised of these things. The proctored midterm and the proctor final apparently, obviously, are very, very heavily weighted, but you will have problem sets that you can do a practice exam that will also count towards your final, or towards your midterm or towards your final. So you can boost your grade by doing that. Yes?
Is it like mechanics where we'll have like the practice exam and we'll use that as a note card?
You can. That is absolutely correct. Yeah, that's helpful. So I'm not a big fan of memorizing. I'm a big fan of organizing your thoughts and organizing the bigger ideas. So yes, absolutely. And then, as it says, generally 90 to 100 is an A, 80 to below 90 is a B, and so forth. And if you're close, I'm never. I try to give you the benefit of the doubt. You work with me, I work with you. We're trying to do the same thing, trying to get you ready for the next class. So that's part of it. So all homework can be scanned and emailed or mailed to me. That's for distance students. Moodle is my best option. But anyway, a student really can't take the exam until they've turned in all the homework. So if you miss a homework exam, you're going to have to still turn it in and get partial credit before you can take the exam, because it just doesn't work otherwise. It's kind of the whole thing. Yeah.
So there's only 1 homework assignment per chapter?
Yes, that's correct. You'll be doing homework. There's usually 2 or 3 vodcasts, sometimes 4 per chapter, and each one of them has a homework assignment associated with it, but you turn it in all together.
Gotcha.
Yep, that's right. And then we have a disability support service statement here. If anybody has an issue, we'll accommodate that issue. And how to drop or withdraw from class. I hope this is not an issue for any of us, but if you do, please don't just quit coming. You need to turn in the paperwork or else you get an F, which really is terrible. All right, and so that's kind of the syllabus. That's the basic layout. Now let's talk about 2 other things today. First is how I want your homework to look and where we can find stuff. And then I guess there are really 3 things. And the other thing is what that math review looks like. So the math concepts pretest or math review is right here on your Moodle page. And this says it's for the spring of 17, which was a year ago. So this should say the spring of 18. But basically we have a little vector multiplication problem and a scalar multiplication problem. Then we have a gradient, finding a gradient of a function in 3 dimensions, a double integral, statics problem. We have a we have a, well, this is a force equals mass times acceleration kind of a problem where the force or the acceleration is not constant. So it's dv dt or dx squared dt squared or something like that. And similarly here, this kind of looks like it might be a kinematic problem. You have to decide if it is or not and solve that. So there are 6 problems. Most people do very well on it, but most people have some questions. Most people, it brings up some issues that you may not have thought of for a while, but most everybody does very well in the end. So you put together your engineering problem-solving skills and do that. So that will be due next Wednesday. And if you don't have it by class time next Wednesday, we can talk about it, and I can help you finish it. But don't like have all 6 problems and get started. I mean, really make a good college try before you come in. So then where are you going to find the material for this textbook? Okay, we have appendices right here. And this is these are just exact copies of what's going on in the book. But take a look at the appendices so you can see what you have. We have conversion tables. Conversions in fluids are so important. Another thing I really like about this version of the textbook is it does not emphasize SI units over imperial units or over US customary units. And in fluids, especially, there's sort of like 2 fields of fluids. Fluids came together from the field of hydraulics and the field of hydrodynamics. And hydrodynamics is very, very mathematically oriented, very scientific. Hydraulics is really like on the ground. It's like boilermakers and guys that are designing hydraulic lifts. And so you see a lot of messed up units. You see a lot of meshed together units. So I think it's really important, especially for those of us who practice in this great country of ours, that we can cope with all of the units of the world. And because we trade with everybody else has to do it too. So it's just it's a good thing to be very, very conversant in. Physical properties of fluids. This is like a very interesting chart, but we talk about viscosity and different fluids, how they behave differently by temperature. And you may have an idea of what viscosity is, but I always tell people it's kind of like that. There's an old expression, slow as molasses in January. That's a very viscous fluid. Molasses in January is a very viscous fluid. Molasses in June, if you've left it sitting out in your counter, not so much. So viscosity is a resistance to flow, is what it really amounts to. It's not really a thickness or a density, which you kind of equate with that. Those are sort of tied together, but it's really just the resistance to flow. And there's a lot of very interesting fluids that exhibit very interesting viscous properties. Some properties, the faster you spin them, they just continue to act in a certain way. Others become thicker or thinner if you move them more quickly. An example of that is like if you have a bottle of ketchup, and if you turn it upside down, and you shake the bottle, or you squeeze bottles work better for ketchup because of this property. But you can stick a knife in it, and it'll start to flow really quickly. You can get all over your hand that way. So, like I said, squeeze bottles are better. Or another substance is ubolic, which is cornstarch in water. It looks like a fluid, but if you pound it really hard, like if you walk across a pool of ubolic, it will become almost a solid in that percussion moment. And so those are kind of properties of viscosity that are very interesting. Anyway, lots and lots of tables because fluids are just kind of interesting and all over the place. There's another thing as well, is that you'll discover as engineers, it's my experience that engineers tend to either like things that sit still or things that move or fluids. And so maybe you're going to be one who likes fluids the most, which I did. So so if you do, this is going to be like right up your alley.
Doesn't UW have a really good water resource?
Oh, yes, they do. They do. They're very, very good. So, yeah, so all this stuff. The thing is, water is awesome because water is, it's not really compressible. It doesn't. It has an unusual property in that when it freezes, it becomes less dense. But it's not a very complicated fluid to analyze. There's some that are, I mean, like hydrocarbon combinations, like oil that comes out of the ground, very complicated because there's lots of different fractions, and there's gas, and there's sulfur, and there's all kinds of stuff in solution, and the temperature and the pressure changes and the composition changes. Water's not like that. Water's pretty constant. And it's also, ubiquitous. It's everywhere. Water is like the most important fluid that we have for so many different reasons. So if you know that water runs downhill and you know some things about water, you can probably make a lot of money in your career just based on that. So water's great. And yes, University of Wyoming has a wonderful water resource program. So there you go. So anyway, I won't go through all these tables with you, but you can take a look and see how these things have been broken down. There's a huge textbook, and there's several copies of it around the college here, called the CRC Chemical Handbook. It's about thousands and thousands of pages thick, and it's all just like tables like that of different properties of fluids, and some solids as well. But so if you ever see a CRC manual, there's one upstairs. There's one in my office. There's one upstairs in the chemist's office, and so forth. So it might be something just for a little light reading that you'd like to look at how these things have been broken down in the laboratory. Yeah, exactly. So we just talked about the property tables, so we're good to go. The honor code, now for you in this class, this should not matter. But if you do end up taking a test with someone else, like if you're taking your test over spring break and you have to have a high school teacher, for example, proctor it, you'd be required to sign a form, and your proctor's required to sign a form, just stating that you understand that this is a big deal. So we want to make sure everybody's on the same page. And it's my experience that most people are fairly honorable, but sometimes in the moment of taking a test, it can become expedient to do things in a different way. How's that sound? So we don't want that to happen. Let me see. I talked about the math pre-test. Oh yes, one of the last things I want to show you is the homework template. I want all of your homework to look like this, more or less. Okay? And this is on the page as well. So all of the elements, and you'll notice first of all, this homework template is dark, but it's on the green paper. So green paper or some sort of a quadro paper, very organized, very spelled out what it is you're doing. The square boxes or the rectangular boxes, you don't have to write those words. That's just telling you what that thing is. So the due date, course number, the number of sheets, your name, all of these things. We always want a picture, the theory, the assumptions, and the solution. So you want a free body diagram, the ideas that you used to solve the problems, things that you had to assume, and the solution. The answer must have units unless it's dimensionless, double underlined, beautifully worked out so that I can follow every thought that you had. Okay? So if you finish a problem, you don't have to have a single sheet per problem, but draw some sort of a dividing line or underline the problem number so that I can clearly see where one problem begins and one problem ends, or the other way around. So, okay. And one thing about this, I don't know, well, I guess this is a little inappropriate, but I'll go ahead and say it anyway. So back in the day, there was a joke about eating a raw turkey with a long-handled spoon. And I won't go into great detail, but basically sometimes students will think that they're like doing something that kind of looks like what they're supposed to be doing, and it's not really very good. And I always think that's kind of like a long-handled spoon thing, where it's just like you're just kind of hoping that you're going to get something done. If you don't know what you're doing, just find out. Just talk to me. Just do your best. But if you have something, because your instructors have been at this a long time, and if you have something that you don't know what you're doing, we get it right away. I mean, it is just like a big flag that says, I don't know what this is, so I'm putting down some cute things that look about in the area of what I think we should be doing. And it might fool your classmates, and it might even fool somebody in the math tutoring center, or in the tutoring center, but really your instructors are going to see through it right away. So if you don't know what something is, that's why you want to lay it out this way, because this is a way of laying things out that just says, I know exactly what I'm doing. Even if I'm wrong, I know exactly what I'm doing. That's what I like to see. So please put away your long-handled spoon and just show me what you know, okay? And if you don't know, come talk to me, because that's what I'm here for. All right, so that's the homework template. I never put up announcements, but you never know. We like to think about, is your computer ready for fluids? It probably is. That's sort of an older document, especially for people who were overseas while they were taking this class from me. I wanted to make sure that we didn't have any surprises at the end of things. So by next Wednesday, you're going to have your math concepts pretest, also known as the math review, done for me. You've got the textbook and the property tables. Here where it says vodcast number 1, introductory material for spring 2017, I will replace that with the vodcast that we've done today, okay? And so anything, and I'll also update this, that the syllabus was actually revised 11018, so that you know that that's good, and I'll get rid of that one, okay? So that's what you'll be doing for next Wednesday. The material for exam number 1, which begins with vodcast 2, which begins in chapter 1, is not visible to you right now. I will make it visible to you. However, you're not, just follow the schedule on your syllabus as to when you have to get started. So there are 4 sections. I should probably just go ahead and show you. So after that, we do chapters 1 and 2. That's section 1. This says material for exam number 2, but it's really the second half. I will update that as well. It's really the material for the second half of the midterm, which is chapters 3 and 4. Oh, I guess I should show you that. In every one of these sections, the textbook chapters are available. So here under material 1, there's homework for chapter 1. This is the entire homework set for chapter 1. So you can see every problem. And when you go to the vodcast, the first one might say, do these 4 problems. The next one will say, do these 4 problems, and so forth. But this is the homework for chapter 1 in its entirety. Okay? Then come down here to textbook for chapter 1. It looks just like you opened up a page in the book. Okay? So everything here in its entirety, including at the end of the chapter, the homework problems. Yeah, so everything's ready to go. Do you guys have any questions for me? All right, well, the vodcasts are fairly formal because I was doing them almost all by myself in here, and it's really weird when you're talking. I mean, I talk to myself all the time at home, but usually about less intellectual things than fluid dynamics. So anyway, but so they're very formal. They may even seem a little, they may not seem like, I have to warn you about something before I let you go. Sometimes I had to record the vodcast many, many times because something wouldn't come through and I would have to redo it. And I would get bored, and I found a terrible habit I had, which was tapping my pencil on the table like this. So if you hear this in the background, don't try to tune it out of your headphones. It's just me being that way. So I apologize. I quit doing it eventually, but one of my former students, Matthew Barfus, told me that he had tried to adjust his headphones so that noise would go away, but it was just me doing that. So I apologize. That's like when you have to record the same thing 4 times in the same day, trying to get something. You're like, your brain is very far ahead of what you're saying, and so that was apparently my reaction to that. So you guys have a great day. Work on the math review. Come see me if you have questions. All right. Oh, and I will not be on campus this Friday. But that's not typical. That's just for it's a personal thing I have to take care of. So, sound like a deal? All right, guys, have a great day. We'll see.